Okay. Yes, so my name's Nick Addison. I'm a developer at Origin Protocol. I do have a number of open source tools outside my day job. So TX2ML does a visualization of traces, like a transaction trace. But today I'll be talking about Sol2ML. So Sol2ML originally started as Solidity 2 unified modeling language, but it's evolved into a number of other things which we'll get into. It's an NPM package, it's a command line interface. So yeah, NPM link, Sol2ML means you can run it from pretty much anywhere on your computer. It's MIT license, which means it's free. So you can copy it, fork it, and do whatever you like. Okay, well, formatting's gone out a little bit here, but that's okay. So the original program was to generate a UML class diagram. So basically you can visualize, and we'll see some examples of what your Solidity contract looks like. It does have some expanded features now, so it's a number of commands. So the storage feature gives you the storage slot layout, which is quite useful. There's a diff command which will basically compare your verified contracts on Etherscan to either local storage, to your local contracts on your local system, typically from a particular commit, or you can compare to another contract on Etherscan. There's a flatten feature as well, which basically, if there's multiple contracts on Etherscan, verified contracts, it'll merge them all together and put them into one file. I don't know whether many people are using that anymore. It does have some smarts about ordering as well, because it knows about what contracts need to go first, but I won't be talking about that. Okay, so the class diagram. Yeah, so Sol2ML class, so that's the actual command. Class is default, so you can drop that if you like. But basically you need to pass in one of three things. So you can either pass in the file name, the Solidity file name. You can pass in a directory, so and it'll look for all the Solidity files under that, and then calculate all the dependencies. Or you can pass an address. If it's an address, it'll go and look at Etherscan and grab the source code off Etherscan or a compatible browser. Now, I was a little worried about whether you better read this, but this screen is effing huge, so hopefully you can see it. So here's an example of the WETH contract. So Sol2ML, put the address in. I've cut out the middle bits of the address. That's what you'll get. You'll get a class diagram, so you've got your variables, your functions. It uses stereotypes to define different types of functions. So we've got the events in there. We've got a fallback function there. We've got the payable identified. If it had modifiers in there, you could also see the modifiers as well, but we'll see some examples later on. You can do it against a local file. This particular example has 3 contracts in the one file. Then you'll see the inheritance, so you can see the generalization of the contracts. Now, you're not meant to be able to read that, although if I had a probably higher resolution on the rendering, you probably could have because the screen's big. But you can put in a directory, so here's the Open Zeppelin, and I'll dump out all the contracts, all the dependencies within them. Yeah, typically it's an SVG file which you can generate, so you can zoom in and have a look. Okay, so I'll talk about 3 diagrams I use in my repos to document the Solidity code. So one is the hierarchy diagram, which gives you the inheritance. Another one is a squash diagram, which basically collapses the hierarchy down, so all the functions in the inherited contracts get pulled down into one contract, and we'll see some examples of that, and then the storage diagrams. So there is a hierarchy diagram. I'll show you how to generate this, but points to note is we've got the Vault core and Vault admin at the bottom, and then from there it's worked out all the dependencies from the inheritance back up. Now the options, you can either do the short option. So for example here we've got the base contract names is like the long form of the option, or just the -B. So at the top there we've got Sol2ML dot. So basically it's going to look for all contracts under that repo from where you're running it from. So base contracts, so that's that Vault core, Vault admin. So you're passing in the base of the contract. So then I'll just follow the tree. It creates a graph and follows the graph and grabs all the dependencies, anything which is linked to that particular contract. And then there's a whole heap of variables to hide stuff. So we're hiding in this particular example, we're hiding the functions, we're hiding the variables, enums, structs, libraries. We're basically just giving concrete contracts and abstract contracts. Here's another example of the OETH oracle. Again, we're passing in two base contracts there to grab the dependencies of. Okay, so here's a squash feature. You may not be able to see that at the back, but we use stereotypes at the end. So if you look at the first one, governor position, it's got the governable at the end there. So that's telling you what contract it came from. So for this particular example, we've got the governable contract at the top, then we've got the base oracle, and then we've got the OETH oracle. So we're squashing and having a look at the OETH oracle, the base contract here. So we can see the first lot of variables are the governable variables, and then you get into the base oracle storage variables. So it's a good way if you're looking at a contract, particularly if you get like a large hierarchy and trying to work out where was the function, where did it eventually get implemented? Was an abstract one? Where is the concrete implementation? It does have other information. So example, we've got our only governor modifier there, and then we have stereotypes. So it marks which functions implement that particular modifier. So again, useful if you're reviewing to making sure you've got your re-entry modifiers on your correct functions. If you've got your, is the only the owner or governor or whoever it is, you've got your correct coverage of your functions. Okay, so I missed some of the options on here. Yeah, so here we have a depth option. So we're putting depth 0. So basically it's not going to show any dependencies on this when you squash it. If you had depth equals 1, it'll show everything linked to one level, and then obviously you can go out further. Here's another example of the squashed function, but you can also take it further. You can hide any private functions or internal functions. You can hide the modifiers, hide the events. This is particularly useful if you're looking at a third-party protocol and you're trying to work out, well, what functions can I call? How can I interact? How can I read from this particular contract? And you're not interested so much in the internals. Okay, the storage diagrams. I'll just give you an example. So here is USDC off mainnet. I read an article, this is probably about 3 years ago, it had a diagram like this, and I thought, oh, this would be pretty easy using the infrastructure I've got to be able to generate this. How wrong I was. It was actually quite hard to generate this. But yeah, it gives you the layout of a contract. So this is, this is working off a, so you're just passing address, so it gets the data from, the source code, sorry, from Etherscan. You can also get the data as well. So here we've got the raw data in the slots, so all the slots and the raw data. And then because we know what the types are, we can actually parse it all. So we can parse the addresses, we can parse even the strings. We saw this morning an example of the difficulty of strings and the different lengths, etc. So it handles all that. So that's using the data option. Now, one thing to point out here is that the storage diagram works against the implementation. And then if it's proxied, you need to use the -s or the storage feature to put your proxy contract, which actually holds the actual data. You do also need to pass in a URL, or you can export a node URL to go and get the storage slots from an RPC calls. You can hide the values, so you can just get a more concise picture. You can also run it on a particular block. So it's useful if there's a particular hack or you're trying to work out what happened in a transaction. You can run it before and after and see the value changes before and after a block. It works with any Etherscan-like explorer. So Etherscan, they've rebadged, most of the Explorers are running on Etherscan, so here's an example of running against Polygon, but most of the chains are supported. You can run it locally, so this is running against a local repo. If you do run it locally, you have to pass in the contract name you're running against. So in this particular case, OETH Oracle. You probably can't see this, but it'll expand out any arrays and struts and show you those. And these can end up being quite big if you've got quite deep dependencies. New feature is you can put slot names in. So it'll take the Keka hash of the slot names and it'll display the data of those. So for example, in this particular contract, we have a hash string which will result into a particular slot, a 32-byte slot, and I'll show you the value of those as well. Running out of time, but I put all these, have one script to generate all these diagrams. So generate the hierarchy, the squash diagram, and the storage, and you can put them all in a README, so it's an easy way of documenting your contracts visually for people who come into your repo. I'll quickly do the diff one. So the diff feature is you can diff a contract which is verified on Etherscan back to your local. So if you're verifying that someone in your team has deployed a contract, how do you know that they've deployed the contract which has passed a particular audit or a particular Git commit or is on a particular branch? This will do it. It'll report whether there's any differences. This one here, they all happen to match. If they don't, it'll show which have been added or removed or changed. And then it uses a Google diff to actually show you the actual differences. So handy tool for verifying what's deployed. And that's it.
Thank you so much. Any questions from the room? Yes?
Yeah, I don't support mappings for that reason. It's too hard. I guess you could pass in, like if you passed in like what he wanted to map, you could probably do, but no, I don't do mappings.
Anyone else? Okay.
Awesome.
So if we don't have any more questions, we can keep moving. Thank you so much, Nick.